Hey there, this is Seth Juarez from Channel 9 coming to you from Mechelen here in Belgium. We're at Techorama 2016, and I have a new guest who happens to be an old guest from the Charles days.
That's right. Yep.
So let's go a little bit back old school on what some of the stuff you worked on before, because you worked for Microsoft, obviously. Why don't you introduce yourself before we get started?
Yeah, so I'm Bart De Smet. I'm originally from Belgium here, so it's coming home over here, and I've been with Microsoft for about 8.5 years, and I worked on WPF first and later on the reactive extensions. So that was the reason to be on Channel 9 quite often as we pushed out new releases of RX.net.
So let's get into reactive extensions for those that maybe don't have a good understanding of it. How would you explain it to people?
Yeah, so one way to think about it is like the way to represent events as first-class objects. So if you think about sequences, like enumerables, those are first-class objects, and you can write queries on top of them.
Sure.
And if you think about asynchronous results, you think about task of T, which is also an object representation of something that has a value in the future. And unfortunately, nothing exists to represent a first-class source of events.
Right.
And that's actually what an observable sequence is about. So an observable sequence is very similar to what a delegate is to methods, which is a function object representing a method, is an observable to events. It's an object that represents a sequence that in the future will have values.
I see, and that's interesting, right? Because like if I'm coming from the IEnumerable ideas, I'm doing a for each var in the IEnumerable of T or whatever it is, and then I do that stuff. But it feels like this is a little bit different, right? I'm pulling from collection values. What's the analogy with RX that sort of helps people understand?
Yeah, the analogy is very similar to event handlers, where events get pushed to you. Like the event callback gets invoked many, many times every time you move your mouse, for example. And so observable sequences you don't for each over, you subscribe to them.
I see.
And you subscribe to them using callbacks, very similar to event handlers in .NET. The difference being that the event handlers are represented using observers, which are objects themselves. And those objects implement the different callbacks that you can get.
And so what kind of update, because obviously reactive extensions has been around for a while. What are some of the cool things that you've seen being built with these kinds of
I think there is a little bit of a correlation between whether a language supports async and await yet or not. Because in the world where you don't have async and await and task, people tend to use observables to represent even single value asynchronous results that come out at some point. So everything people do today with async and await in C# were things that people have mimicked before using observables, like using link queries to represent the continuations or sort of like the chaining of different actions. After that, you see people doing a lot of things what it's really intended for, namely event processing. So a good example is TX, linked to traces, which is actually a layer on top of RX, which uses ETW and SQL events and all sorts of event sources, and you can write queries on top of it to say, give me the average CPU on a 1-minute window and correlate it with other events. So you can sort of see, oh, there's a CPU spike, what were the events associated with that? So you can do rich analytics over local streams of events.
And so these events are essentially getting pushed to you, and you have methods that sort of help correlate these things as they come in.
Exactly.
But these things are coming in at different times. How do you synchronize these kinds of events?
So there's a bunch of operators in RX that allow you to deal with those different out-of-order arrival kind of things. So, for example, we have joins, temporal joins, which allow you to take events, associated duration with them, and sort of join them based on overlapping in time.
So it's like a window that you
like a window, exactly. So we have windowing operators, we have grouping operators, we have operators to do joins. Actually everything you expect from link, but now in the world of temporal semantics, as opposed to being just the enumerable semantics. And in addition to that, we have something called historical time schedulers.
Right.
So like if you have a log file, what you can do is this pretty interesting sort of turning the wheel, right? You start with a log of something that went bad in the system. Like I'm now working in Bing, and quite often we do that. So we get a log of something going bad, and you start looking for correlations between what's in the log file, what's in the ETW traces, what happened at that time based on some other logs that you have. And then you can formulate using RX a hypothesis that just in virtual time simulates what happened at that time and write some temporal queries. Like maybe you see two things coinciding, like high CPU, high memory. Maybe there's a GC going on. And so you write those queries on historical data, and then later you take out the virtual time aspect and you run them in real time. So now you can see on a real system, something bad is about to happen based on what we learned before.
And that's interesting, right? Because now you're using reactive extensions to not only look at past data, to correlate events, but you're looking at it to future data to sort of describe sort of events that might happen.
Exactly, yeah. And so that's an ideal pattern for things like, say, intrusion detection is a good example. Like you have logs, you find a pattern where you can indicate, oh, intrusions happened here. You have the proof that they happened because you had a post-mortem of those bad things. And then you can take exactly the same code. There's no change to the code, and now use it on real-time event stream.
So let's talk a little bit more about what you're working on now, which maybe has some tie back, I understand, maybe may or may not have some tie back to reactive extensions.
Yeah, quite a bit actually. So if you think about LINQ, right, like classic LINQ, you have LINQ to objects and LINQ to SQL.
Sure.
And LINQ to SQL allows you to write the same style of queries against some remote service. In that case, a relational database. So what we're doing now inside Bing is we have an event processing system which we call Reactor. It's actually running on top of Service Fabric.
Wow.
So you can actually find information, a white paper online of how we do that. And so what we do there is we allow people to write event processing queries using the RX language, reactive extensions, and upload them into the cloud. And so a good example of that is everything that happens in Cortana today for proactive experiences. For example, you arrive in a new city and you get weather alerts, or you have to catch a flight. Those things are actually driven by the technology I'm working on right now called Reactor. Wow. So if you're sitting on your phone and you say like, please remind me to catch flight BA48, what will happen is that a reactive extensions query gets uploaded into the cloud, gets instantiated on one of our query evaluators in the cloud, and it's sitting there. And it's just sitting there reacting to events about flight delays and that kind of stuff, sending you notifications. So it's very similar to LINQ to SQL in the sense that you have the same language and you upload it to some remote service. The main difference being that when LINQ was built, it was done to help solve the impedance mismatch between like local collections and the database. We didn't have the database equivalent for RX. We didn't have like a service that does event streaming. And so we have an ideal language to describe those queries, we just didn't have a service. And so what we do with Reactor today is actually build such a service that can do distributed event processing using the RX language.
And that's interesting. So if I understand correctly, Reactor is a service.
Yep, that's right.
And what it does is you sort of give it a query.
Yep.
But in the reactive way, it sort of pushes back notifications when stuff matches that query.
That's right, yeah.
What are the kind of things that you can give to Reactor that will process events for you?
Yes, so, well, first of all, there's a bunch of streams that are defined in our system or that happen to come into our system. So that's the same thing as subjects in RX. Subjects are event sources, if you will. And so you can go to Reactor and say, just like in SQL, you can say create a table, you can say create a stream. And then some event publisher can publish those things in. So today, we have things like breaking news, flight information, weather information, sports scores, like a whole bunch of Bing data flowing into our system in real time. And then the kinds of queries you can write is pretty much the same thing as what you can do in reactive today. So like if you can write a windowing operator to, for example, aggregate sports scores over a 1 hour window, you can do that. If you want to build something simple that's close to PubSub, meaning events come in and you just want to have a simple filter and filter the events and then maybe send them to some endpoint or insert them into a database, you can do that as well. So what we've really done is we've taken all the operators from RX and made them first class into that service. So that service understands things like filter operators, projection operators, just like SQL understands where and select, right? But for much more operators in the temporal domain.
And that's interesting now because now you're saying that this Reactor thing lives in Bing, right?
Yes, yeah.
So you can ask a Bing type question and it will feed back data to you when that data has arrived.
Yes, yeah, that's right, yeah.
That's amazing. So you could do all sorts of crazy things like put your name in there, and then it will message back when something hits Bing that has your name in it.
That's one scenario that could be enabled using this. Like today we don't do that type of thing. It's like for predefined sets of queries for certain experiences like Cortana, but that's totally, where the value comes in, right? It's like you want to react to changes in the world's information. So as something changes in terms of maybe, somebody gets a first child, you have the entity that represents a famous player and you're interested in getting, notifications about anything that happens in the person's life. So when the entity gets updated and you say like, well, now we're going to update the entity with a link to a child or something who also has an information card in, our index, then you could get real-time notifications about those things as well, yeah.
So what are some of the things that Reactor's being used for? You talked a little bit about Cortana, but can you sort of flesh that out a little bit more? How is Cortana using Reactor?
Yeah. So literally, if you go on your phone, whatever brand it is, right, and you go into the Cortana app or in the built-in Cortana experience, and you say, for example, I want to track the flights, or I want to be notified when to leave to the location of my next meeting, right? The thing that shows up the little map saying you have to leave now. When you turn those things on, what happens is that the Cortana client talks to the Cortana service, formulating that intent, saying like, there's a meeting at that location, say on the Redmond campus, I work in Bellevue, I have a meeting on Redmond, so it will basically create a query for you. And then that query is submitted to Reactor as an expression tree. So there's no foreign language here. That's kind of one of the other things.
Right.
We don't invent a DSL, a domain-specific language. We just submit the intent to Reactor as a reactive extensions expression. And so that query for, when you need to leave to your next meeting is effectively a join between the geo-coordinates that are streaming from your phone with, the road information of the roads that you have to take between point A and point B. And so that query is literally something like subscribe to the stream of events of traffic incidents, which contain the expected delay because of a traffic incident.
Right.
Subscribe to that 1 hour before the meeting, start analyzing the data, sort of know when the user has to leave, and fire off a timer at the point the user has to leave in order to make the meeting in time. And when that happens, a signal is sent to an HTTP layer, a notification layer, which ultimately brings it up into Cortana as a toast notification, saying you have to leave now for your next meeting. And so the whole central experience there, modulo the delivery part, the HTTP egress part, the signals that come into the system, and also the programming, but all of that central piece actually happens in Reactor as like one standing query. Just like you would go to SQL and say, I want to insert a T-SQL statement here, and it needs to run all the time, right?
Wow.
So that's what's going on.
That's interesting. So now, with Reactor and Cortana, it like can plan for you because it's looking at things that you're going to do. It's looking at where you are, and those events are sort of coming together, and there's a correlation.
That's right. Yeah.
What other scenarios are being enabled by Reactor other than Cortana? And then where do you see this going in the future?
Yeah, so there's a bunch of internal scenarios that we're enabling right now that have to do with services in Bing, needing this kind of reactive, live updates. A lot of the scenarios are actually personal scenarios right now because Reactor is optimized to host millions of small queries as opposed to a couple of big Firehose queries a la some other systems like Spark and those kind of things. So a lot of the scenarios are personal scenarios. There's also a whole bunch of things that just have, deal with different information silos being connected in real time. So for example, if you do a search in Bing, you can get information cards on the right. That information card is, a representation of some entity information that we know about a certain user or a certain place or a certain whatever. Often, those things live in different silos, and so Reactor can help to connect a lot of those things so that the freshness of a lot of information sources is actually maintained in real time. And so it's kind of this glue that allows us to react to changes in information and then update a whole bunch of stores and caches around the whole system as well.
And then you can make decisions say you subscribe to N events, you can make decisions about the interaction of those events.
Yep.
And then maybe push a notification to the user.
Or like update some catalog that contains inferred correlations. Like one team that's using us is, for example, the inferences team. That's a team that does a lot of machine learning in the cloud. And so there you also want to have like a lot of high fidelity signals coming in, but infer even higher fidelity inferences out of that, right? With confidence scores and what have you. And so that can then happen in real time, which is of course much more powerful than cranking the wheel every night, in a batch job saying like we have terabytes of data. Let's look at those. So we do more incremental processing that way.
That's awesome. So where can people go to find out about Reactor?
Yeah. So there's a bunch of online sources where you can find the word Reactor correlated with Service Fabric.
I see.
I have a couple of talks that I gave at NDC and so forth. We are still looking at what the path will be to open source some of this stuff. So we have rx.net, and what we kind of did when we started Reactor is we said we want to take the good things of Rx, like the language, but we also want to get reliability across multiple machines into the system as well. And so we sort of started from a clean slate building a new interpretation of reactive with the same language with a lot more facilities to do state persistence, scheduling of queries, because you now have to imagine having millions of those things sitting on, hundreds or thousands of machines in the data center, right? And so you want to compact those things, make sure that, and that's why we use Service Fabric, make sure that those things are reliable. Like if you have a query which is doing, a running sum of the number of touchdowns in a game, because that's the information you want to infer out of sports events. Well, you don't want to lose a touchdown, so you have to store those aggregate values. And in Reactor, we have to persist those things, and we use Service Fabric for that. But if you take a look at, say, reactive in process, well, it's just a field somewhere in some operator, and it's not persisted, right? If you use it locally. And so Reactor is really all of this, servicification, if you will, of reactive extensions. And so we hope to push out a bunch of those facilities going forward. One thing I have sitting here actually is some project I've done like expression futures. The thing we actually do is we ship expression trees from client to server, and we also ship expression trees between services in the Bing data center. Now, expression trees are a feature that was introduced in C# 3.0, and they lack support for things like statement nodes and the async and await expressions. And so what this is actually a fork of the Roslyn compiler, which we hope to contribute back at some point. It's completely available publicly, which actually extends the C# compiler with support for expression trees, containing async and await, conditionals, and that kind of stuff. Because you really want people to be able to write natural queries, right? Using our service without hitting any language limitations. And we squarely put our eggs in the basket of internal DSLs. We don't want to invent a new language with our own syntax, highlighting, and IntelliSense. We just use whatever C# has, but we need to sort of iron out some of the limitations to expression trees to be able to do that. And so this is something people can already download. They can actually install this copy of Roslyn and actually play with expression tree support. That includes a lot more language features compared to what we had available before. And there's also a little tool here called RoslinPad, which is some linkpad-like tool, which compiles Roslyn code fragments to expression trees. And the next thing we hope to actually ship is a serializer for expression trees, where you can take an expression tree, .NET expression tree, and basically transport it in a JSON format from one machine to another. So that allows you to sort of have code move to the data, as opposed to data move to the code, which is very important.
And that's interesting, right? Because now with this, you'll be able to serialize expressions and send them, to example, to something like Reactor. Or does Reactor have its own expression that you have to give it, because it's got to serialize it somehow?
Yeah. So there's nothing foreign about Reactor expressions, effectively. The Reactor expressions are just a highly normalized form of the .NET expression trees. And what I mean with highly normalized is we erase all sorts of type information, .NET reflection information. We try to sort of get it, if I have to put it theoretically, to the simply typed lambda calculus. We make it as simple as Lisp was, Lisp as expressions. And that also means that we can do interoperability. So we have a prototype of the expression tree format also in TypeScript that people can use to actually formulate those expression trees and actually send them to the same service, regardless of what client language you're using.
Well, that's awesome. So we spent a little bit of time talking about Reactor. Is there anything else you'd like to point us to? Do you have a blog or something, or maybe a website that we can go to start learning more about these things?
I used to have a blog. It was quite active, but it's gone a little bit more silent over there. But there's a bunch of videos on Channel 9, obviously, that you can find. You can also look on the Roslyn Depot and the .NET Depot. I have a whole bunch of pull requests there that have to do with changes to the Roslyn compiler and the .NET Expression Tree API. People who are fanatical about the expression trees will actually be pleased to know that in the next version, or in the first release of .NET Core, we will actually have support for interpretation of expression trees as well, not just compilation. That's actually the code that existed for Windows Store applications is now available to everyone, and that's quite important if you're building, a high-performance service like we do in Bing. Sometimes you want to use the interpreter, and that's kind of a little counterintuitive. And the reason for that is if you just evaluate an expression only once, the cost of compiling it is much higher than evaluating it.
Right.
And so the interpreter approach there helps a lot. And so that's one of the things that I help to contribute back to the .NET Framework source code, and I'm actually hoping to ship a lot of goodies that we have in Bing to the public. Yeah.
That's so awesome. Well, thanks so much for spending some time with us. We gotta get back together and do some more Channel 9 stuff.
We should sometime. Yeah. All right.
Again, thanks for being with us. Thanks for watching. We're here in Belgium for Techorama 2016. My name is Seth Juarez. This is Channel 9, and we'll catch you next time. Take care. Would you explain it to people?
Yeah. So one way to think about it is like the way to represent events as first-class objects. So if you think about sequences, like enumerables, those are first-class objects, and you can write queries on top of them.
Sure.
And if you think about asynchronous results, you think about task of T, which is also an object representation of something that has a value in the future. Yeah, so I'm Bart De Smet. I'm originally from Belgium here, so it's coming home over here, and I've been with Microsoft for about 8.5 years, and I worked on WPF first and later on the reactive extensions. So that was the reason to be on Channel 9 quite often as we pushed out new releases of RX.NET.
So let's get into reactive extensions for those that maybe don't have a good understanding of it. That's interesting, right? Because like if I'm coming from the IEnumerable ideas, I'm doing a for each var in the IEnumerable of T or whatever it is, and then I do that stuff. But it feels like this is a little bit different, right? I'm pulling from collection values. What's the analogy with RX that sort of helps people understand?
Yeah, the analogy is very similar to event handlers, where
Hey there, this is Seth Juarez from Channel 9 coming to you from Mechelen here in Belgium. We're at Techorama 2016, and I have a new guest who happens to be an old guest from the Charles days.
That's right.
So let's go a little bit back old school on what some of the stuff you worked on before, because you worked for Microsoft, obviously. Why don't you introduce yourself a bit?
Unfortunately, nothing exists to represent the first-class source of events.
Right.
And that's actually what an observable sequence is about. So an observable sequence is very similar to what a delegate is to methods, which is a function object representing a method, is an observable to events. It's an object that represents a sequence that in the future will have values.
I see.